Hello everyone, welcome back to my channel. So in this video we are going to learn about Singletone frequency modulation. Okay, Singletone FM, and from Singletone FM we are going to see different types of FM also. Okay, so if you are first time to my channel, please consider subscribing and help me to do more videos like this. So in the previous video I have discussed and I have derived the formula for standard time domain equation of FM signal. So if you have not watched that video, please I am providing the link in the description, the playlist of this analog communication, so you can go there and see the video and again come back here to understand Singletone modulation. Okay. So in the previous video we have derived that the time domain equation of FM signal is given by AC into cos of 2 pi fct plus 2 pi kf into integral 0 to t m of t dt. Okay, so this is the standard time domain equation of any frequency modulated signal. So now we are taking the case of Singletone. So what is Singletone? If the message signal consists of single frequency, if the message signal consists of single frequency, then the process of modulation is called as Singletone modulation. Okay, then the process of modulation is called Singletone modulation. So in Singletone modulation what we consider is m of t is equal to am into cos 2 pi fm into t, that is we know the frequency here. So in the general case we have taken m of t. So we don't know frequency here. It represents a band of frequencies. Okay, so it represents band of frequencies, and if the frequency is single, then it is called as Singletone FM. Very simple. Okay, now what is the, now we are going to derive the standard time domain equation represented by S of t of Singletone FM. Okay, S of t of Singletone FM we are going to derive. Okay, again we are taking only this. So in this expression, if you substitute in the place of m of t this value, that is am cos 2 pi fm t, we get the time domain equation of Singletone FM. Okay, that's all. So AC into cos of 2 pi fc into t plus 2 pi kf integral 0 to t am into cos 2 pi fm into t dt. Okay, so am is a constant, you can take outside, so AC into cos of 2 pi fct plus 2 pi kf into am I'm taking outside, so left over is integral 0 to t cos 2 pi fmt. So integral 0 to t cos 2 pi fmt is sine 2 pi fm into t divided by 2 pi fm. Okay, 2 pi fm. So limits are from 0 to t. So 2 pi gets cancelled, right? So what is left over? AC into cos of 2 pi fc into t plus, here what is left over? kf into am by fm. Kf into am by fm into, if you substitute the limits also, you'll get sine 2 pi fmt only. So if you substitute the upper limit, you will get sine 2 pi fmt, and if you substitute the lower limit, you will get sine 0, which is equal to 0. So you'll get only sine 2 pi fm into t. Okay, so this term kf into am by fm, kf into am by fm. So what is kf into am? Again we have delta f by fm is called beta, where beta is called as modulation index. Beta is called as modulation index in fm. Okay, so it be this term beta is called as modulation index in fm. Okay, so how depth is the frequency changed with respect to this? Okay, so or depth of modulation, we'll call it as depth of modulation. So this is called as modulation index in FM. So this is represented by AC cos of 2 pi fct plus beta into sine 2 pi fm into t. This is the standard time domain equation of Singletone FM. Okay, so this is the standard time domain equation for any Singletone time domain equation. S of t is equal to AC cos of 2 pi fct plus beta into sine 2 pi fm into t, and beta is called as modulation index or depth of modulation in the case of FM, as we have mu in the case of AM. Okay, so this is the standard time domain equation. And next is types of FM. Okay, so types of FM. So there are two types of FM, or the FM is classified into two types. Okay, right, so this classification is depending on beta value. So modulation depending on the value of modulation index. Depending on the value of modulation index, we have two types of FM signals. First one is narrow band FM. Narrow band FM signal, narrow band frequency modulated signal. Okay, so in short we will call it as NBFM. Okay, so narrow band frequency modulated signal. So for this, beta value is less than 1. Beta value is less than 1. If beta value is less than 1, then that type of FM signal is called as narrow band FM signal. Okay, so if an FM equation is given for you, first of all you have to find the value of beta. Okay, so that if beta is less than 1, we can say that it is narrow band FM signal. Second is wide band FM signal. Wide band FM signal, in short we'll call it as WB FM signal, for which beta value is greater than 1. Okay, so if a standard time domain equation like this is given for you and asked to find the parameters of different parameters, we'll discuss later. So if you are asked to find these parameters, first of all, first thing what you have to do is we have to find the value of beta, so that we can classify that as either narrowband FM or wideband FM. Okay, because both the FM signals have different formulas for calculating the total power and bandwidth. So for calculating PT and bandwidth, total power and bandwidth, we have different formulas for NBFM and WBFM. So first thing what you have to do when you are solving for problems, I'm telling you, so if you are given with a standard time domain equation in Singletone, the first thing we have to do is we have to find the value of beta, so that you can classify whether it is a narrowband signal or wideband signal. Okay, correspondingly you can apply the corresponding formulas for total power and bandwidth. Okay.